You might think you understand, but do you really? Most people get this wrong. The ultimate explanation of the Monty Hall problem. Are you on team switch or team stay? This problem once sparked a massive debate across America. Even after being mathematically proven, people still refused to accept it. Even 30 years later, it remains a hotly debated topic worldwide. But when people hear my explanation, they often say, "I've never heard such a clear and easy to understand explanation before." I actually arrived at the theoretical solution nearly 30 years ago in real time. Back then, I thought, everyone will understand it soon enough. But recently, I found out that this problem is still being debated. That made me realize how meaningful my explanation actually is. So, let's break down the Monty Hall problem in a way anyone can understand. What is the Monty Hall problem? There are 3 doors, and behind one of them is the winning prize. You pick one door first. Then, the host opens one of the remaining 2 doors, revealing a losing option. Now, you must decide, switch doors, or stay with your original choice. Even mathematicians were divided on this question. What do you think? The Great Debate of 1990. In 1990, the brilliant Marilyn Vos Savon, with an IQ of 210, made a bold claim. Switching doors increases your chances of winning. But America's mathematicians erupted in anger. That can't be right. The probability doesn't change, they argued fiercely. A massive debate followed, and eventually, the mathematics proved she was right. But even then, the general public refused to accept it. Is switching doors really the better choice? The answer is yes. Switching doors doubles your chances of winning. Let's break it down in a simple way anyone can understand. The key to this problem is understanding what the second choice actually represents. At the first choice, there's a 1 in 3 chance that you pick the winning door. That means there's a 2 in 3 chance that you picked a losing door. Now, here's what happens in the second choice. Since one of the losing doors is always eliminated, the situation changes. If you do not switch, you're betting that you picked the correct door from the start. Right arrow, the probability of winning in this case is 1 in 3. If you do switch, you're betting that you initially picked the wrong door from the start. Right arrow, the probability of winning here is 2 in 3. And because the host always removes a losing door, you're guaranteed to be left with the winning door if you initially picked a loser. In other words, even though it seems like a 50-50 decision, it's actually a choice between a 1 in 3 chance and a 2 in 3 chance. Conclusion: right pointing arrow. Of course, switching gives you double the chance of winning. Simple, right? I believe this explanation makes it crystal clear for everyone. Why is this debate still going on? Even though the math was proven long ago, many people still refuse to accept it. Mathematical proofs are hard to grasp intuitively. Many people instinctively believe that the probability doesn't change. Later, computer simulations were run tens of thousands of times. Finally, people started accepting the result. Yet, even today, this problem continues to spark emotional debates worldwide. The Monty Hall problem is a perfect example of how human intuition and mathematical truth can conflict. So, do you accept this explanation? Or do you still feel unsure? Let me know your thoughts in the comment section. On this channel, we explore fascinating topics about math, probability, and even political and economic issues. Be sure to subscribe and like for more great content.
世界は素晴らしいこの世界は素晴らしいあなたといられるこの世界は素晴らしい